Okay, let's continue talk about the interest problem. The other example, Candy has $70,000 to invest and wants an annual return of $2,800, which requires an overall rate of return of 4%. So you multiply $70,000 by 4%, you will get the $2,800. Okay, she can invest. She can invest in a safe government insured certificate of deposit, CD. Certificate of deposit, but it only pays 2%. For CD, you get 2%. To obtain 4%, she agrees to invest some of her money in non-insured corporate bond, paying 7%. How much should be placed? How much should be placed in each investment to achieve her goal? Okay, so she has two options. CD, insured certificate of deposit. It has low risk, but the interest rate is just 2%. The non-insured corporate bonds will pay 7% interest, but of course it will have high risk of losing the money. It's the common sense. If it is insured, of course the interest rate will be low. If it's non-insured, if it has a high risk, then it will have a higher feedback interest rate. Okay, so the question is, she wants the interest return, the return 4%. How can she divide her investment in order to achieve the 4% goal? Okay, so now let's see. So she has two options. two options, so you are going to separate them. So let X represent the amount to be invested in the bonds, corporate bonds. Okay, X dollars is invested to the bonds, then 70,000 minus X is invested to CD, insured certificates of deposit. Okay, so just cut this big pie into two parts. One part is put for the corporate bond, the other part is put to the CD. Okay, now let's see. For bonds, she has the principal X. The interest rate is 2%. So the total interest, it's just 1 year. The interest is X times 2%. So it's a 0.02 X. 2% is a 0.02, right? X interest is principal times interest rate times 1 year. We're talking about 1 year. And for CD, 70,000 minus X is the principal. Oh, no. Bond is 7%. My bad. Bonds is 7%. This is 7. It's a 7. Here's a 7. For CD, the rate is 2%. Here's 2%. So the interest is 70 minus X. This is a principal times 0.02 times interest rate. Again, we're talking about 1 year. So you add these two together, the sum should achieve her goal. What is her goal? Her goal is $2,800 per year. So this is the equation, the essential equation, right? Okay, so in this equation, there's a one variable. So let's try to solve this variable. So this is a 0.07x plus 0.02 times 70. It's a 1,400. So 0.02 times 70 is a 1,400. And minus 0.02 times x is equal to 28,000. Okay, and then 0.07x minus 0.02x is 0.05x. 28, you move this 1,400 to the right, it becomes minus. 28 minus 14, so it's a 1,400. Okay, you move here, it becomes subtraction. 2,800 minus 1,400 is a 1,400. And then x is 1,400 divided by 0.05. Okay, it's times 20, so it's $28,000. Okay, so $28,000 is amount in the bond. She should invest $28,000 in bonds. The other part, the rest of the part is 70 minus 28. So it's $42,000 in CD. So this is 70 minus 28. So it's a 42. Okay. So this is this answer the question. The question says how much should be placed in each investment. So this amount of money is placed in the bond. This amount of money is placed in the CD. Okay. So that's the investment problem. And next, let's talk about, okay, investment problem. In this section, just remember this simple interest formula. PRT, principal times R times T, PRT. This is a essential formula you need to memorize. Okay, now in the section, the part 3, the mixture problem. Solve mixture problem. Mixture problem, you just put something together and try to see the percentage. Okay, so mix together. Let's see the example. So the manager of a Starbucks store decides to experiment with a new blend of coffee. Okay, she will mix some B grade Colombian coffee that sells for $15 per pound. 15, no, not 15, $5 per pound. With some A grade Arabica coffee. That sells for $10 per pound. To get 100 pounds of the new blend. Okay, so you put the B grade, A grade together to get a new blend. The selling price of the new blend is to be $7. Is to be $7 per pound. Okay, and there is to be no difference in revenue from selling the new blend versus setting the other type. Other types. How many pounds of the B grade Colombian and A grade Arabica coffees are required. Okay, so the thing is that we put this the grade B and the grade A together. We sell for the price $7 per pound, and the condition says there's no difference in the revenue. It means if we sell 100 pound, you see here we sell where is it? 100 pound of such new blend. Each pound is $7, so 100 will be $700 income. But if we separately sell B and A grade, we should get the same amount of money. So that is a requirement if there's no difference in the revenue. We don't lose money or we don't earn money. We just want to get some new blend to get some promotion possibly, okay? Or get a different flavor. Okay, so of course, here is a $7 per pound. If you get all B grade, definitely you will earn money. If you get all A grade, you will lose money. So you need a perfect balance about the A grade and B grade so that you have the same revenue. Okay, so let X represent the number of pounds of the B grade coffee. So you have B grade coffee X, and then 100 minus X represents the number of pounds of the A grade coffee. You're going to get a blend a total 100 pound. X represent B grade. Then 100 minus X will represent A grade. Okay, so for B grade, you have X pounds. Then what is the price, the total money? So the price is 5 per pound. So the total is a 5X. This is a total money. Price times a unit. And for A grade, you have $10 per pound, but you only have 100 minus X pounds. This is the money, the revenue for the A grade. Add them together. This should be equal to the revenue for the blend. Blend is $7 per pound times 100, right? In this part, we're talking about, in this equation, we're comparing the revenue. We're comparing the total money. Okay, now let's compute 5X plus 100 times 10. 10 times 100 is 1,000 minus 10 times X. 10X is equal to 700. So 5X minus 10X is negative 5X. 700 minus 1,000 is negative 300. So you move 1,000 to the right, it becomes 700 minus 1,000. So it's a negative 300. So X is negative 300 divided by negative 5 is 60. Okay, so X is 60. So it means the B grade coffee will be 60 pounds. Then the A grade coffee will be 40 pounds. And yeah, so you're going to answer it. So the manager should blend 60 pounds of the B grade and 40 pounds of the A grade. Okay, so that's the answer. All right. Okay, let's see the next. So that's a mixture. Mixture, basically, you are going to consider what is not change, which one is the same. No difference means they are equal, it's not change. You keep the identity, then from left side, you compute this no difference quantity. On the right side, you compute the no difference quantity from the other direction. Then you can get the equation. And solve the equation, you get the answer. Part 4, solve uniform motion problem. Uniform motion just means constant speed. Remember, uniform motion means constant speed. So in the uniform motion formula means the distance, total distance, is the speed r times t. R, speed is a distance over t, so it's a rate. So that's why they like to use rate times t. So it's a distance is equal to the rate times the time. Okay, this rate is speed. It's called speed in the motion problem. The rate is called by different name for different problem. Okay. This is the example. So Tanya, who is a long distance runner, runs at an average rate average speed of 8 miles per hour. Okay, so whenever you see the average rate, average speed is constant, it does not change. 2 hours after Tanya leaves your house, you live in your Honda and follow the same route. Okay, if your average speed is 40 miles per hour, is 40 miles per hour. How long will it be before you catch up to Tanya? How far, how long means the time. How far will each of you how far will each of you be from your home? Okay, so how far means the distance. Okay, now let's see. So this is a home. And this is a route. And Tanya is a long distance runner. She, after 2 hours, she's here. It's 2 hours. And then you start to drive a Honda to catch up Tanya. So possibly after several hours or several minutes, you're here and your car is here. The same route. Okay. So how do we set up the variable? Let t represent the time that it takes the Honda to catch up to Tanya. Okay, so after t hours, the car catch up Tanya. Okay, this is t hours. Here is t hours. Right? Okay, now let's see what is the common quantity. Actually, the distance traveled by the Honda and the total distance traveled by Tanya will be the same because you catch up Tanya. So Tanya in total runs 2 plus t hours. Tanya's speed is 8 miles per hour. So this is the total distance run by Tanya. 2 plus t is time times the speed is the distance. And the car Honda has speed 40 miles per hour. The Honda travels t hours. So this is the same distance. Okay, so that's the relation from the graph. Okay, then let's compute. 8 times 2 is 16. 8 times t is 8t, so it's 40t. We move 40 to the left side, it becomes 80 minus 40t, negative 32t. We move 16 to the right side, it's negative 16. Right? And t is a negative 16. 16 over negative 32 is 0.5. Half hours. After half hours, 30 minutes, the Honda will catch up to Tanya. This answers the first question. How long will it be before you catch up Tanya? How far will each of you be from your home? Actually, you are here inside the Honda. Tanya is here. The distance is the same. The distance is the same. So it's a 40 times 0.5. 40 times this 0.5 is 20 miles. Right? right? So this quantity is shared, is actually the reason you put this equation. So it will take Honda half hours to catch up to Tanya. Each will have gone 20 miles. So this is the total distance. Each will have gone 20 miles. Tanya already ran 20 miles. Okay. Okay, so this answers the question. Next example. A motorboat has upstream a distance of 24 miles on a river whose current is running at 3 miles per hour. The trip up and back takes 6 hours. Assuming that the motorboat maintained a constant speed. Relative to the water. What was its speed? What was its speed? Okay? So this problem is a little bit complex. Okay, so how do we solve it? You see, you have a trip. The trip is 24 miles. And the current is this direction. Assume whatever direction. Current is this direction, 3 miles per hour. And at the beginning, it is stream up. The motorboat has stream up. And they are looking for the speed. Assume, okay, so solution. Let x represent the speed of boat relative to the water. Okay, okay. So if your speed is 0, if you have the boat is not a motorboat, and you do not handle it, then the boat will follow the current with a speed 3 miles per hour. If it is a motorboat, have a speed relative to the water with x miles per hour, then technically the speed of the motorboat relative to the bank is x minus 3. X minus 3. You have to spend some of the speed to be against the current speed. So the x minus 3. This is a upstream. If it's downstream, the speed relative to the bank is x plus 3, because even you don't have speed, you will follow the current with a speed 3 miles per hour. So you have to add this 3. Okay, so that's a speed. Here's the speed upstream, this speed downstream. The total distance is always 24 miles. Okay, then distance over speed. You see, the distance is rate, speed times t. So distance over speed is t. Distance over t is a speed. So these are three important relations. So here, distance over speed is time. It means if the boat heads upstream, it will take 24 over x minus 3 hours to cover this 24 miles. Downstream, 24 over x plus 3. This is a downstream. Add them together, you have up and back trip. Up and back trip is here. The trip up and back takes 6 hours. So this is the equation. Okay, so here is the equation. Now let's try to solve the equation. This equation is a little bit complex. Let's try to solve it. How do we solve it? We find the common denominator. X minus 3, x plus 3. So here's 24 times x plus 3 plus 24 times x minus 3 is equal to 6. And we move this denominator to the right side. We will get here the numerator 24x plus 24 times 3. It's what's that? 72 plus 24x minus 72. Here's a 6 times x minus 3, x plus 3. It's x squared minus y squared, so it is x squared minus 9. 3 squared is 9. So 72 negative 72 then cancel. You have a 48x is equal to 6x squared minus 54. You see, they all have the common factor 6. So we divide by 6, divide it by 6. You will get 8x is equal to x squared minus 9. So you get x squared minus 8x minus 9 is equal to 0. You have a quadratic equation. Do you still remember how to solve this quadratic equation? You factor negative 9 as negative 9 times 1. And you do the cross product. You get a negative 9, 1. The sum is negative 8. It's exactly this 8. So you put x here. You get x minus 9 times x plus 1. So by the zero product property, x minus 9 is 0, or x is equal to negative 1. But the problem is we don't have a negative time. We don't have negative speed. This is dropped. So the speed relative to the water is 9 miles per hour. 9 miles per hour. And that's it. Okay, so this problem is a little bit complex because its relation is not that straightforward. So you have to figure out the relation and then set up the equation to get the answer. Okay, so read this example again and try to understand how it is solved. And also, you have the upstream, downstream difference. Upstream, use your relative speed minus the current speed. Downstream, relative speed plus current speed. Part 5, solve constant rate job problems. Okay, an example. At 10 a.m., Danny is asked by his father to weed the garden. From past experience, Danny knows that this will take him 4 hours. Okay, working alone. His older brother Mike, when it is his turn to do this job, requires 6 hours. Okay. Since Mike wants to go golfing, with Danny, and has a reservation for 1 p.m. Okay, so 10 a.m., 1 p.m., they're only 3 hours. He agrees to help Danny. Assuming no gain or loss of efficiency. When will they finish? If they work together. Can they make the golf date? Okay, so let's see. So assume they will finish the job in T hours. Let T represent the number of hours if they work together. Okay, let's check. So if you finish a job in 2 hours, then every hour you will do half of the job. If you finish the job in 3 hours, every hour you will you will do 1/3 of the job. If you finish it in 4 hours, every hour you will finish the job, do the job 1/4 of the job, right? The parts of the job. So in 1 hour, they work together, no gain, no loss of efficiency. In 1 hour, because Danny will take, it will take Danny 4 hours to finish the wheat job. So every hour, Danny will work out 1/4 part of the job. Danny will work out 1/4, 1/4 part of the job. And same reason, because his older brother Mike will need 6 hours to finish the whole job. So 1 hour, Mike will finish 1/6 of the job. So every hour, 1 hour, Danny work out this, 1 hour, Mike work out this. And if they do together, this is how much the part of the job Danny and Mike finish or do. And it is equal to 1/t, because they work together, take T hours, right? It takes T hours for them to work together. So 1 hour is a 1/t. And this is one way to compute the efficiency. This is the other way to compute the efficiency. This is the efficiency comparison, right? The efficiency comparison. Okay, then you just solve for it. So 1/4 plus 1/6, you get the least common multiple. 4 and 6 least common multiple is 12, and 1/4 is a 3/12. 1/6 is 2/12. Add it together, it's a 5/12 is 1/t. Then you flip two sides, you will get t is equal to 12/5. 12/5 is 2 and 2/5. 2 and 2/5 hours. What is 2 and 2/5 hours? So 1 hour 60 minutes. And 2/5 hours, it's a 60 times 2/5 is 24 minutes plus 1 hour. So they will finish the job in 2 hours 24 minutes. Okay, they start at 10, i.e. they finish it at 12 p.m. 24 minutes. Their reservation is at 1 p.m. They can catch up the reservation. They can catch up the reservation. So it's good for them to work together in order to play the golf. All right. So in this problem, you see here we compare the efficiency because they have this assumption, assuming no gain, no loss of efficiency. no gain, no loss of efficiency, right? So whenever you have a problem, you may have a different quantity which is not changed. Here, the efficiency is not changed. The previous problem, the total time is not changed. So you have to work out the concrete problem, figure out which quantity is unchanged during two different computation, and then you set up the equation. Okay, so for this section, we already did some examples, but that definitely it's not enough. You have to work out some examples, recommended exercise by your own, and then you will have the feeling what is changed, what is unchanged, and how to set up in equations. Okay, so do the exercise, ask me question if you have. Okay, we finish this video. Thank you.